In this video, I want to bring to you the TryHackMe Advent of Cyber 2021 edition, Day 8, Task, Exercise, and Activity. Now we can hop on over to my screen here, get the party started. I'm over online at tryhackme.com/Christmas. Now if you were to navigate to that webpage, you could scroll down and find the button here that will say join for free, ready for December 1st if you're not already having fun with the Advent of Cyber. That will bring you over to this next page here, and we could scroll down to Day 8. Now this one is titled Santa's Bag of Toys, and in case you hadn't realized, hey, this is a activity brought to you by me. I put this one together, so I hope you have some fun with it. I hope you enjoy it. I hope there's some good learning and education value in there. But hey, I'm open to constructive criticism. If you happen to think this thing sucked, or you think there could have been anything better or different, or just represented in a different way, I want to know that feedback. So please, please, please drop it in the comments. Let me know what you think. I'm excited, and I hope we have some fun with this. So let's get after it here. I'll read this to you as kind of the obligatory thing that I think we should all be doing. So that way we get all on the same page here. We get the learning all done. This intros with McSkitty was notified of some terrible news. Santa's laptop, which he uses to prepare his bag of toys for Christmas, is missing. We believe that a minion at the Grinch Enterprise stole it, but we need to find out for sure. It's up to us to determine what actor compromised the laptop and recover Santa's bag of toys. Now, if you hadn't noticed, over on the far top right, you can see in the task there is a button that will start a machine for the specific task. We wanted to give you an environment that you would be able to exercise and play in. I'll go ahead and press that Start Machine button, and it will, I believe, pop open to the right-hand side here. Give it just a moment. Okay, now it has popped up over here to the right. This gets a little bit in the way of all the words that I want to read, so I'm going to end up actually popping this out. And by the way, actually, let me make a note here. This is not an attack box. This is not a machine that you can use as kind of headquarters and you could use to then run all your scripts and your code and your commands to attack something else. No, we actually wanted to prepare this virtual machine for you to use for the analysis so you don't have to go download any tools or reach out and grab anything from the internet that you might not be familiar with already. It's accessible in this environment. So you don't need to do any attacking from this Windows machine that you'll see over on the right-hand side. I am going to pop this out though. I believe this is the full screen icon down on the very bottom left there, and it will display it. There we go. Connect to a little Apache guacamole and have that loaded up AoK for us. Now I'll go ahead and exit that split screen view and scroll back down here, and we can get back to the storyline. Alrighty. So unfortunately, the Best Festival company had minimal monitoring tools on Santa's laptop. He is the boss, after all. All we have to work with are some PowerShell transcription logs that we were able to remotely recover just after the laptop went missing. You can find the transcription logs within the Santa's Laptop Logs folder on the desktop of the attached Windows virtual machine. If you aren't familiar, PowerShell transcription logs capture the input and output of Windows PowerShell commands, allowing an analyst to review what happened and when. Typically, PowerShell transcription can be enabled via group policy, and this is actually the most common technique. For the sake of getting this in the learning environment for just this single machine, it's just kind of hand-crammed through the registry. So bear with me, sorry. Another method to turn on this logging is configuring it via the Windows registry. And you can see the registry editor picture and screenshot here. This is the specific configuration location that's necessary. And really the enable transcripting option is the most important setting. The others to define an output directory, there is one by default, but I just wanted to throw in a specific location and actually turn on the invocation header so you could see how PowerShell was started and all of these tasks actually began. Now note, you do not need to run these commands yourself. While you do not have to use these commands for these tasks, these will turn on the PowerShell transcription logging for a local host, for the computer that this setting is applied to. If entered in administrator command prompt. You could run these down below, and that would go ahead and actually trigger and turn on and enable all of that setting there. This will just actually go in and do the process of making those changes within regedit or the registry editor. You can see that GUI application here. This command line, these regadd commands that would be run from cmd.exe, that would do the same thing and maybe speed you up because it's automated, right? Entering the commands. Power user in the command line. The Windows registry is a large database of operating system settings and configurations. It's organized by hives. with each hive containing keys and their corresponding values. You might be able to think of the Windows registry as sort of a dictionary. I wouldn't strictly say a database, but a dictionary, and that, hey, some word has its own definition, right? Well, word is a key and a value is the definition. And that's all stored on these different pages, which could then be kind of paralleled to hives in the Windows registry. PowerShell transcription logging can be enabled in this way per user by each specific account on the computer via the HKeyCurrentUser registry hive, or across the entire computer via the HKeyLocalMachine registry hive. Thankfully, Santa's laptop had this enabled machine-wide. That's going to come in handy for all the digging that we'll end up doing here. Now, this is an important note that I mentioned earlier. For this task, you'll interact with the Windows virtual machine to perform your analysis. For the sake of the storyline, the machine you're interacting with is not Santa's laptop. It's just your machine to be able to do the investigation and uncover all of the tracks here. You will have sample files that were recovered before the laptop was stolen in this kind of situation here. So the answering questions, it says, hey, read the premise above, start the attached Windows analysis machine, which we have done, and find the transcription logs in the Santa's laptop logs folder on the desktop. So I will toggle back over here to the display, and you'll notice this one right here, the Santa's laptop logs, is displayed on the desktop. I'll make that a little bit bigger for you so you could actually see this. And I'm going to end up toggling my own windows when I click on these and try to use the start menu. Just going to open up the File Explorer super duper quick, and I'll zoom in on all this so it's a little bit more visible to you. You can see one of these folders is simply named, hey, Santa's laptop logs. And inside of this folder are other files here. You could see these are the PowerShell transcription logs given with a kind of random name. The file name there is a bit arbitrary, but there is a date and timestamp noted at the very, very end there. Now, alongside this on the desktop, we have a Shellbags Explorer folder, a Bag of Toys file, which is kind of odd and peculiar, and a local copy of CyberChef. So hopefully you have everything you need for this task. Let's hop back on over to the tab here. We can mark that as completed as we've opened up that folder. Now this says each transcription log is a simple plain text file that you can open in any editor of your choice. So if you're working in Notepad or WordPad or Sublime Text or Visual Studio Code, or if you're in the holy wars right between VI and Emacs and all that, you can use maybe Nano, I don't know, whatever floats your boat, right? While the file names are random, you can get an idea as to which log comes first by looking at the date modified or date created attributes within the Windows File Explorer, just as we were navigating in. Or even just looking at the timestamps, if you wanted to make your eyes suffer with that, before the file extension, the .text there. Now we could open up the first transcription log. You can see the commands and output for everything ran within PowerShell, like who am I and system info. So let's go take a look at that. I'm going to open this up. We'll move back into that Santa's laptop logs folder. And now this very, very first one, it is ordered right now, but if I were to zoom back out, you could see maybe the, actually I might have to set it to the view here for details. There is a column here for date modified. And of course, if you wanted to right click, you could also add another column for date created. And if you wanted to toggle that to search or maybe sort in one direction or another, ascending versus descending, we can see that this very, very first one was created at 6:35 p.m. a few days ago. So that would be our number one. That is the, I believe, S3K JAD, however you wanted to say that. So we could open that up within Notepad, and this opens right here. Now I'll zoom in so this is a little bit more legible for you, but check it out. This is a Windows PowerShell transcription log. Here's a timestamp of when it was invoked and the username that this was ran and executed as, how PowerShell started. And if you aren't familiar with PowerShell, by the way, I didn't mean to just completely gloss over this. Opening up Windows PowerShell is this kind of spooky, scary, but also super cool blue box where you might be able to enter, run, and actually invoke specific commands. In PowerShell, those are called commandlets, and it's actually kind of processed in a different way when you're working through streams. Normally in Linux, if you're used to the Linux command line, you'll pipe some program's output into the standard input of another program. In PowerShell, you're actually piping objects or things with more properties and variables and information that could actually get funneled along through the pipeline and actually gives you a lot more power, hence the name PowerShell. It's kind of cool, but it varies and is different from the Windows command prompt or cmd.exe. You might be familiar with that one, that kind of spooky, scary black box, but that's where all, the power users are at. That's where all the system administrators, the ethical hackers, the blue teamers and red teamers, all the cybersecurity folks are on the command line. So come join the party if you aren't already here. You can see how this PowerShell process was actually invoked with a run as, in case it was invoked with some sort of extra permissions or privileges. And you could see, the machine host name or the kind of operating system that it might be. And of course, the actual host application that's running the instance of PowerShell. PowerShell doesn't have to be invoked through that blue window that I popped up. It's actually just a DLL, the dynamic link library that lives in kind of the internals and backbone of the Windows operating system. There are a lot of interesting things, and you get into conversations of blue teaming and defense, and people say, a lot of threat actors and a lot of adversaries are taking advantage and abusing PowerShell. And some might say, why can't we could just disable PowerShell? We could just turn it off. Truthfully, it's not that easy. It's so baked into the core of Windows that trying to disable PowerShell might just break stuff and do more damage. So we have the PowerShell version and a little bit of other information that would be accessible here on the invocation header. And that's what you're looking at in this kind of asterisk and star separated section there. Now, whenever a command is ran in another block here, you'll see that specific command time that it was executed, again in Unix time, or a representation of seconds since the epoch, January 1st, 1970, I think? Yeah. So we could see, as if they were entering it right on the command line within PowerShell, they ran the who am I command. And that told them, hey, you're Santa on Santa's laptop. The username and the host name there. Now, additionally, we see another command ran, system info, and we can see all the output that comes through from that. And that also gives us kind of everything we might have seen in the invocation headers, but a little bit more detail. This actually tells us we are looking at a Microsoft Windows 11. Looks like Santa's up to snuff. He's doing some of the cool, hot, new things out and about in the world. He's rolling that new, fresh Windows operating system. Checking out the processors. And you could actually check out what hotfixes or patch or KB knowledge bases have been installed. That's kind of a neat thing that you might find some output of the system info command. Now, notably, the who am I command, the system info command, and even down below when you see the net user command ran, all of those are what I would call old school cmd.exe commands. Those aren't PowerShell commandlets. Normally in a PowerShell commandlet, you'll see a very verbose notion of a get or set or verb, and then a hyphen to denote, okay, what are you going to do this to? What verb action are you going to perform on what thing? You'll have a noun just following that. So verb hyphen noun is normally the structure and syntax for PowerShell commandlets, but oftentimes you could have an alias or actually a given shorthand, nickname, and convenience function, or just another representation of a long and verbose commandlet that you might run, like typing out get MP preference status device configuration letterhead, etc. Way too long. Maybe you could just convert that to alias GD or something. Quick and easy, much more like a Linux or Unix command prompt command like ls. Anyway, that's it. Let's get back to it. I know I'm talking too much. You guys are having fun without me. This question asks, what operating system is Santa's laptop running? And we just gathered that, the OS name field there. We could slap in and copy and paste what we had previously, Microsoft Windows 11 Pro. Go ahead and submit this. Now we want to review each transcription log to get an idea for what activity was performed on the laptop just after it went missing. In the second transcription log, right, second in air quotes, it seems as if the perpetrator created a backdoor user account. So let's go check that out. We had this PowerShell transcription log open in Notepad, but let's move on to the next one. And here, I'll zoom back in again, and we'll see what we're up against. Maximize this for a moment. Ooh, and we see some other interesting commands. In fact, Now they're still running as Santa, but they might have invoked this with a specific permission and privilege because it suddenly put their path or their current prompt where they are in the file system within Windows System 32. They may have invoked this with administrator privileges. If that actor stole the laptop and had physical access, they might be able to do that easy enough. They run this command net user Santa with a 4 for the A little bit of leet speak, Grinch stole Christmas /add. Now, if we break this down, this is actually adding a new user account to the computer. If you haven't seen that net user syntax before, that's how you could do that from the command line. The username here is Santa with the 4 for a little A leet speak, and the password was Grinch stole Christmas. You can see Windows kind of whined about this. Hey, the password you entered is longer than 14 characters. Maybe some old school computers, oof, will not be able to use that account. Do you want to continue with this? And the threat actor or adversary said, yep, totally cool. They entered Y for this confirmation here. And it successfully added this account. Then we see the perpetrator adding this new Santa backdoor account, allegedly for nefarious purposes, right? Trying to hide and blend in with a stupid 4 for the letter A there, maybe masquerading a little bit. And they add it to the administrators group. So now that user has all of those superpowers and strength, special permissions and special privileges that the admin of the computer does, as if they were the regional owner. Here you can see they run net user to verify this. The Santa backdoor account, the spooky one, has been added alongside the original Santa account there. And if we scroll down a little bit more, we can see, oh, they're verifying and checking, has it been successfully added to the administrators group? And there, just down below, there's our spooky Santa alongside the original Santa. They do some magic to actually just display the SID, or the, I believe, security identifier, for each of these user accounts using WMIC, or the Windows Management Instrumentation. That gets into a little bit of stuff that we don't exactly need to dive into for the purposes of this video. If you're willing to press the I believe button with me, you're more than welcome to do so. But WMI and WMIC could do some cool, shady stuff. So just a little Easter egg in case anyone wanted to go explore or maybe Google around at what more that command is or what it could do. But if that TryHackMe task was asking us for what password has been set for this new user, we saw it in the original command here. Net user Santa and Grinch stole Christmas was the password that it had specified. So let's right click and copy that. I'll go ahead and paste it in right there. Excellent. Now it says in one of the transcription logs, the bad actor interacts with the target under this new backdoor user account and copies a unique file to the desktop. Before it's copied to the desktop, what is the full path of the original file? So let's go back to those transcription logs and let's kind of keep exploring and investigating what else might have occurred on this device here. I'll zoom back in after I open that new one. You can see in the invocation headers now, we are running as the username Santa with the 4 for the letter A. So now the actor is interacting with that backdoor account. You can even see them verify that running the whoami command. Looks like I am, in fact, the backdoor. And it changes directory to the environment variable. This is that cd command to change directory. The environment variable within PowerShell is, again, another kind of store for all the potential pieces of information or data that it might be able to access more easily because it's stored in a variable or some box that's kind of waiting for you to retrieve and get the contents out of. And specifically in the $env, the $ prefix is how you represent variables in PowerShell, by the way. This $env will denote it's an environment variable, and the user profile would bring them right to the C user's Santa, or their username as a directory and folder. User profile always will bring you to your home directory, or how you might equate it to on Linux anyway, and it's just going to the desktop there. Then we see the actor ran a copy command just below, and they copied something interesting. A C user Santa app data, some of the maybe more internal application data folders, local Microsoft Windows USR class.dat or user class, however you might want to represent that, And then they tried to dir and verify, hey, did that actually succeed? They wanted to check out the directory contents, see what is current listing in their directory or the present working directory. And they don't actually see it. So they try and run that one more time. Looks like there's a shortcut to Microsoft Edge, the web browser on the desktop, but they weren't able to track down the user class that they had just tried to move and copy to the period. Period being the current directory, or where you naturally are at the moment in the file system over here on the desktop. So without seeing that verification, they actually run dir tac force, or dash or hyphen minus force, however you'd like to see that, to say, hey, show me everything that's in this directory, even like hidden files or system files that might not normally be displayed in a regular content listing. And there, in fact, now you can see the user class.dat file has been properly brought in. So I'm going to take that as the good indicator that this file, the full path here, I'm going to right click and copy this. This in fact is what was copied to the desktop. Bring that back to TryHackMe. Copy, paste, slap that in there. Go ahead and submit, and that is the correct answer. And now here's an interesting thing. It says the actor uses a living off the land binary or a lol bin to encode this file and then verifies it succeeded, checking it one more time, right, by viewing the outputted file. What is the name of this lol bin or the living off the land binary that was used? Let me open up this living off the land link here. Oh, looks like it actually brought us right to certutil.exe, which is what we might have been able to see if we peeked a little bit further down, used to encode and re-represent the data and contents of that USR class.dat. This program, certutil.exe, is typically a program and application used for handling certificates, right? Cert utility, certutil.exe. It is a native and inherent and always typically installed within a vanilla Windows operating system. It's one of those binaries or programs or applications that is always typically very well trusted, more than likely going to be on a fresh Windows host. So oftentimes threat actors or attackers, right, kind of checking out the MITRE attack framework, they might take advantage of the tools already present on the operating system so they don't have to drag in or bring in their own tools, right? You go out on vacation, you're touring a new place in the world, you want to live like a tourist, right? You want to go see, maybe live off the island and not bring any of your own stuff. That's the idea here. It's so that we don't have to bring in any rogue or unnatural things into a new environment that a threat actor might be trying to work with there. Now let's scroll down and see that in action. You can see they use this command, certutil-encode on that user class.dat file, and then the following argument is santa.dat. Reviewing back to lolbins, if I go to search for that certutil.exe, you could see down below how or what could really be done. What and how could be done. Maybe certutil could be used to download files from any rogue arbitrary place on the internet, or it could maybe slap in some alternate data streams, try to hide content, maybe malicious, maybe nefarious inside of other files, or encode and decode data in base 64. Another encoding or representation of data and contents. And this is in fact the syntax that we see here. Certutil tac encode, given the input file name, what we're starting with, the source file, and then the output or the destination that we're working with, the encoded output file name. So looking back here, it looks like we have a santa.dat as the newly created file. And they verified this by actually typing out all the contents or trying to view and display what was successfully encoded. Now this looks like a certificate, but it's not. It might just be considered one because certutil.exe was originally used for working with certificates. But the threat actor, the bad individual, they're just using this to kind of maybe copy and carve this data out. User class.dat is in fact a binary file, so they want to represent it in plain text or maybe some characters that they might more easily be able to exfiltrate and store or place elsewhere, right? So all the way down below, if we scroll down through this entire thing, you can see there's a lot of nonsense. It starts with a whole lot of A's, base64 encoded null bytes. And if I scroll down my horizontal scroll bar on the right, you can see there's a ton of content. Moving way down to the very bottom here, that is the end of all the data, and it then exits to close that PowerShell session. Okay, so let's go review this. I'll close this tab, and now it is in fact the certutil.exe binary, or the lolbin or living off the land binary that was used to encode the userclass.dat file. Go ahead and submit this. And now we can chat about this a little bit more. It says the userclass.dat file was encoded with base64, which thankfully you can decode and recover the original user.class file. Userclass.dat file. Base64 decode the contents between the begin certificate and end certificate markers within the transcription log with something like CyberChef, right? Which you have a local copy of on your analysis machine. So let's go do that. I'll go ahead and copy all of this shenanigans again. I'm holding Shift on my keyboard, so I could go ahead and just select all of the section in between the begin certificate and end certificate markers. Because again, that's just boilerplate that certutil.exe would use. But we want to go ahead and use that CyberChef link, the shortcut that we have on our desktop here. I'm going to go ahead and double click that. And there we go. It'll open up a web browser and we have a local copy of CyberChef to work with. It'll take just a moment to load. Okay. Now let's come into life here. We could go ahead and paste in all of that base64 data. And there's a lot of it, right? You can see, oh, whatever, what is that, 3 million and bytes or so? But it is base64, right? So we want to decode it with the from base64 operation on the left-hand side. You might already be familiar with CyberChef. I think we've used it a bit in some of the other Advent of Cyber rooms and tasks here. But it will churn through all of the work to be done there, and now we have a new file. It's not printable to us. We don't exactly know or can't tell what it is, but we could go ahead and download or save this. I'll call it just that original userclass.dat, because that's what we knew the original file name was. Now when we save that, it'll prompt us, hey, where do you want to put this? I'll go ahead and just drop it on my desktop here. Looks like Firefox will naturally want to put it in my downloads, but I'm going to actually just drag that over to my desktop. There we go. Now it should be displayed and visible there, userclass.dat, as we've seen before. Now let's continue reading. This file can be used to aid in our investigation. The userclass.dat file contains shellbags, or artifacts contained within the Windows registry that store user preferences when viewing folders within the Windows Explorer graphical user interface, which is kind of cool, right? Like the same way that we've just kind of been navigating and bumping around between our desktop and our downloads and the Santa's laptop logs, when we saw all those columns and headers like the date modified or date created, all those are sort of cached or stored. And what you had seen with an Explorer is something that could eventually be retrieved later if you were to carve out data from these shell bags. This is exactly what we're going to do here. If you could carve out this information, you could get an idea as to what user activity was performed on the laptop before it was stolen or compromised. If you want any more details on Shellbags, you're strongly encouraged to do some extra research or reading. I have a link here, and there's a ton of great stuff that SANS has put out in this regard. And I'll pull up this link here. This is the just a Medium article that another individual wrote on really cool things, kind of the idea behind Shellbags. And if you want to get a little bit more behind the scenes than what I'll showcase in this walkthrough here, I would really recommend, hey, check it out and read it. Some super good information in there. Now, if you wanted to extract the Shellbags information within this user_class.dat file, we could use a tool. We could use a utility, in this case specifically the Shellbags Explorer graphical utility put together by Eric Zimmerman. So all credit and kudos goes to Eric for his fantastic work and contributions to the information security community. And there are a lot of other renditions of this just as well. For folks that are maybe a little bit more well-versed or just like to, again, be on the command line rather than the graphical interface, there is a shellbags.py or other Python scripts or other tools and utilities you can find online, you can find on GitHub that will do this exact same sort of thing, maybe carve it out in another automated way that you might prefer. When we were writing this task, when I was putting together this room, I actually had suggested and maybe included, do we want to do this in the Linux world with the attack box? But I wanted to give you a little bit more feel of the Windows realm, since this is, of course, where Shellbags come from. The Shellbags Explorer utility is found readily available inside the Shellbags Explorer folder on the desktop of your Windows machine with the application name shellbagsexplorer.exe. So that's what we'll go ahead and open up here. Back to my desktop, that's that Shellbags Explorer folder. Now, if I zoom in here, you could see we do have a couple options. I believe there even is a command line representation of this running on Windows. But if you wanted to click on that graphical user interface, you could use that Shellbags Explorer utility. This will pop open here in just a moment. And there we go. All right, I have the Shellbags Explorer open here. And now let's go back to the TryHackMe read here. Oh, it just needs us to read the above and open the application found on the folder in your desktop. Yep, we can mark that as complete. It says, with Shellbags Explorer open, use the top bar menu to select File and load offline Hive, and then navigate to the location that you saved this decoded user_class.dat file. Load in the file and begin to explore the shellbags that are discovered. All right, so let's hop on over here. We want to use this File menu, load offline Hive, and we knew that we just stored that over on the desktop. This is me selecting the user_class.dat file just there. Go ahead and open this. And in just a moment, it's a, hey, we actually found some shellbags. I don't know how well this will be displayed. This text is a bit small, but if we click OK on this little notification, hey, success, it was completed, we could find over on the left-hand side kind of a file browser navigation style structure. And we could see on the desktop, there were previous things viewed by this potential threat actor, this adversary, this person who stole Santa's laptop. Looks like they actually found a Santa rat, interestingly enough. We could click on each of these, kind of poke around and explore. You could see that the settings or details and summary will be updated as you move around and navigate. There's a santarat.zip file, apparently. There was the bag of toys. Ooh, we could find Santa's original bag of toys here. He had a bag of toys.zip, and I could expand some of these. Oh, okay. So bag of toys had a bag of toys.zip file. And what was in Santa Rat? Santa Rat main. Digging through this. Ooh, I see a .github folder. I see client, message pack, server. What's in server? Connection and algorithm. Plugin. Plugin has a little bit more information too. Oh, plugin is ransomware. Oh, uh-oh. Someone's doing some pretty shady stuff on Santa's laptop here. But let's go back and let's see what we were trying to gain insight into. Under the desktop folder, there seems to be a suspicious folder named Santa Rat. Could this be a remote access Trojan? Or malicious software, right? That was used for further nefarious activity on Santa's laptop? Unfortunately, from just shellbags alone, we don't have all the pieces of the puzzle here. We only have insight on the folder names and sometimes files, right? If we're lucky, we saw the bag of toys.zip. And there's the column data, right? We could navigate around and we saw, oh, the created on, modified on, access on, metadata there. But we don't have the file contents themselves like we did with this user_class.dat. We just kind of got lucky when the threat actor had displayed out and maybe made a mistake in that, hey, we wanted to verify the contents were really there. That allowed us to recover this file. So if we were to drill down into the folders here, and maybe we could find something that might indicate how we could better track down what this Santa Rat software, or this program, if it is a program, what it really is, right? So what specific folder name here clues us in that this might be publicly accessible software hosted on a code sharing platform. Now, if you aren't familiar with this, it's totally okay to go ahead and check for a hint. And I would recommend even just doing that all the way along if it's something you just aren't too sharp on yet. No shame in that. Really recommend it. It's all here to learn. It says the folder name starts with a dot or a period. Ooh, and that actually clues us in because we did see there is a .github folder here. Is that what it's looking for? We could copy that name, .github. I'll copy that. Again, paste it in. And that meets the criteria. It starts with a period. And that, a .github folder, is one of the natural internal and inherent folders created when you're working in a GitHub repository. GitHub being an online code sharing platform. So we're starting to put the pieces of the puzzle together here. It says, additionally, there's a unique folder named Bag of Toys on the desktop. This must be where Santa prepares his collection of toys, right? And this is certainly sensitive information. This is data that the threat actor could have compromised. So let's find out what is the name of the file found in that folder. Well, we already dug into it. We saw the bag of toys directory here in our Shellbags Explorer. We saw a bag_of_toys.zip. So that is what we'll submit there. There we go. And it says, next, we want to track down this Santa Rat software. It might just be as simple as searching for the name of the software on the suggested website over on GitHub, right? Now, there's this important note here. The TryHackMe Windows analysis machine does not have internet access, so you'll need to go ahead and explore this in your own web browser. So I am going to do exactly that. I am going to move over to my web browser here, just naturally on my host, and I'll go to github.com. There we go. Now, we could search GitHub. If you don't have an account or if you needed to sign in or however you like to use GitHub, honestly, we just want to search over here in that search button, that search bar. Let's search for Santa Rat across all of GitHub. And ooh, we have some interesting stuff here. Santa Rat has config files for a GitHub profile. Okay, whatever. And then we have Grinchiest Santa Rat, a remote access Trojan to use against Santa's laptop. This sounds like what we're looking for, right? Let's go ahead and explore Grinchiest Santa Rat. And I'll scroll down here. We can explore what this thing is or what the code was. It is a remote access Trojan to use against Santa's laptop. Remote access Trojan to use against Santa's laptop, shamelessly ripped off of DC Rat. So hey, let me break the fourth wall for a little bit. Put down the illusion of performance. For folks that keep up with my content and my videos, you might have seen that we did some malware analysis on an application called DC Rat. Turned out to be a super cool story. I would really recommend you check out that video. It was an individual that was putting together some of the software for like a university or school project, and it was actually legitimately used to do some damage in the real world. So, hey, super interesting thing. If anyone's fascinated by that, please go check out that video. I'd love to see your support. Thanks so much. All of this looks to be boilerplate from the previous DC Rat source, or probably what this came from. Santa Rat looks like, just a ripped, shamelessly stolen copy of it. But it's this individual, this creator, Grinchiest, that is putting this together. Here we go. Let's click on his repository. Let's click on his profile. This is Grinchiest. It says he's a Grinchman at the Grinch Enterprises, here to cause trouble. Oh, this is totally our guy. All right, let's go ahead and submit that. This looks like what we're looking for here. The name of the user that owns this Santa Rat repository is Grinchiest. Let's go and submit that. And it says, explore the other repositories that this user owns. What is the name of the repository that seems especially pertinent to our investigation? Oh, so if we went back to Grinchiest's profile, we could see that he has some other repositories just here in his dashboard and his profile page. There is Santa Rat, of course. Looks like a Santa Rat template, but most importantly, I'm sure you saw it probably stick out like a sore thumb. It's the Operation Bag of Toys planning for the Christmas heist. So that's got to be what we want to submit there. The name is Operation Bag of Toys, separated by hyphens. Now it says read the information presented in this repository. All right, let's hop back over there. Click on that. And here's a README. It says, for this Christmas, Grinch Enterprise will rig Santa's bag of toys. We'll steal Santa's laptop and compromise his bag of toys, removing all the good toys and replacing them with bad things. Well, they posted an update, supposedly. We've successfully stolen Santa's laptop and have replaced his bag of toys. Now, Santa's bag will only be filled with badness. Coal, mold, worms, ants, mildew, boogers, earwax, sand, dirt, and spiders. Christmas is ours. Oh, geez. Who comes up with this stuff? Let's go back to TryHackMe here, now that we've read this. It says, it seems as if the actor has, in fact, compromised and tampered with Santa's bag of toys. You can review the activity in the transcription logs. Oh yeah, we hadn't finished going through each of those yet. It looks as if the actor installed a special utility to collect and eventually exfiltrate the bag of toys. What is the name of the executable that installed a unique utility the actor used to collect the bag of toys? Ooh, so let's hop back over to our desktop here while we were looking at Santa's laptop logs. And then the fourth now is where we are at. So let's zoom in on this and take a look. Still working as our backdoor evil nefarious Santa account. And ooh, we have some cool PowerShell where we're actually starting to do something a little bit more spooky, or like pure PowerShell, right? We create a new web client object and we try to download a file from a website given here. samglesk.net, UHARC, UHARC command install.exe. And it saves it and executes this. UHARC cmd install.exe. I'm assuming that's the file name we're looking for. And then we try and run this utility. It has been installed, right? So now it's going to be present in program files. And UHARC cmd, I'm assuming, is the name, bin for binaries, and they run this uharc.exe. Ooh, so the output here is UHARC, a high compression multimedia archiver. A little old school, looks like copyright back in 2005. Really hard to make sense of what all this potential parameters and arguments are, but let's see, is this the answer that we need to submit? uharc-cmd-install.exe. Let's submit that. Yep, that's right. And we might have been able to make more sense of that had we gone and explored that next transcription log. It says, in the last transcription log, you can see the activity that this threat actor used to tamper with Santa's bag of toys. It looks as if they collected the original contents with a UHA archive. Ooh, what is that? There's a link here. Zooming in on some file info. What is a UHA file? It's a Windows file archive compressed using UHARC compression. May create smaller files and archives than .rar compression, but decompression typically takes longer. Okay, so it's like, here it is. A UHA archive is similar to a zip. Yeah, it's like a zip file or RAR archive, but faster and with better compression rates. It's very rare to see, right? It's a little obscure, a little esoteric, but it looks like the Grinch Enterprises are pulling out all the tricks for us. Okay, so you can see the actor compressed the original contents of the bag of toys with a password. Ooh, let's go check that out. We were in this transcription log, but I want to check out that very, very last one here. Still has our backdoor account, our evil, nefarious actor. And there we go. Oh, it looks like we run program files, UHARC A to create a new archive, I'm assuming. TAC PW, looking for a password, and TAC R, probably to recursively move things. And eventually it will create this bag of toys.uha output file, copying and extracting or compiling everything inside of the bag of toys original desktop folder. So all of Santa's original bag of toy contents has now been put into this archive using a password. Well, wait a second. We have a bag of toys file on our desktop, did we not? Bag of toys. Oh, and there's a UHARC icon. So let's double click on this. Maybe we could extract this, but hey, it needs a password. This archive is encrypted. Please enter a password. Okay, so our next task has to be figuring out what that password might be. But this is a GUI and graphical user interface for the UHARC or UHA archive. Looks like they were using the command line utilities, and we can see that in the PowerShell transcription logs. But again, keep things a little bit easy on us in the Windows analysis VM. We can kind of operate with that graphical user interface. If you'd like to explore and play it by hand, maybe you could go put that into your host if you wanted to and use the command line copy. It does naturally work on Windows. I haven't found a Linux rendition of it yet. I don't know if one even exists with that software dating back to 2005, but I have had success with it running under Wine, or the Wine is not an emulator, or the Windows. It's a program that lets you run Windows programs under Linux. So if folks are familiar with that or they'd like to explore it, again, a little extracurricular exercise for the reader, right? Let's get back to our transcription logs, though. We saw that this archive was created, and then they deleted everything from Santa's bag of toys. Just this del command to remove or delete things. And then they created new files by echoing content and redirecting it out to a new file. There's that greater than symbol. It looks like the word Grinchmas got thrown into coal as a file within the bag of toys folder. And they did this again for mold, and again for worms and ants and mildew and boogers and earwax. Okay, great. Thanks so much, Grinch Enterprises. This very, very last line here looks like it does up compressing and creating a natural zip archive. Yeah. bagoftoys.zip under that bag of toys directory, replacing what would have been the original file with this now bad one, full of all this gross, bad stuff. So Santa's bag of toys has been full-on compromised. Turns out we're going to have to do some due diligence to find out how we could recover this. We are unable to see what that specific password was that was used to compress and create this UHA archive in just the transcription logs. Maybe we could find it somewhere else. Following this, the actor looked to have removed everything from the bag of toys, as we saw with that del command, and added in all these new things like coal, mold, worms, and more. What are the contents of these malicious files? Oh, so we totally saw that, right? In our logs, we had an idea that they were adding in Grinchmas and making that the contents of each of these new files. So Grinchmas should be the answer there in all caps. And now let's kind of continue on. It says, we know the actor seemingly collected the original bag of toys, but maybe there was a slight OPSEC or operational security mistake, just like them displaying out the contents of our user class.dat file. We might be able to recover Santa's bag of toys. If we review the actor's repository for its planned operations, maybe in the commit messages, we could find the original archive and the password. Ooh. Okay, so this is going back to GitHub, right? So I'm moving back to this other GitHub tab, and we're in that Grinchiest Operation Bag of Toys repository. GitHub will store every change that you end up making to a project or a source code or repository that's pushed by differentials and commits. So if you ever wanted to see the history or the version changes within GitHub, you could take a look at what all those commits were. Let me zoom out here just a moment because it actually was hiding this button or icon for the commits. It looks like there are in fact 5 commits, and we can see the history here. So the Grinchiest actor ended up updating the README, referencing Santa's new bag of toys. And it actually had a note that was clobbering Santa's bag of toys. And when they stole Santa's bag of toys, the original planning for operation way back in the past here, we could see, Okay, so it added and created content in this readme.md file, but that's all the change there. If I keep scrolling around, that's all we see. Let's go back and let's step into that next commit and what was done in the repository. Looks like it actually added a new file. It showed one changed file, and it was a bag of toys.uha, a binary file, the compressed original source to Santa's bag of toys. That's what we're after. But it needs the password. Oh, okay. And actually, if we take a closer look at the commit message, it looks like it has it just here as a sort of subtext. PW, that's got to mean password, right? It says the Grinchiest Grinchmas of all. Man, these Grinch guys are so selfish. So I'm thinking that's got to be our password. Let's say we tracked it down, right? Let's mark this as completed. So we took a look through those commits. And it says, what is the password to the original bag of toys.uha archive? Hey, you don't need to perform any password cracking or brute force attempts for those of you trying to speed run this thing. Nope. We're just in it to learn and kind of explore and be curious here. But if I went back to this original bag of toys file and we tried to paste in the Grinchiest Grinchmas of all, which is what we've just uncovered is the password, maybe we could extract this. I'll hit OK here. Ooh, and I have an error on reading archive file. Did I copy that AoK? Oh, looks like it didn't allow me to copy in and out from this little Windows VM. So let's type that in by hand. The Grinchiest Grinchmas of all. And note that that is in camel case. If we go back, you can see capital T for the, capital G for Grinch, Grinchiest, Grinchmas, capital O for of and all. Now when I click OK here, ooh, now we have all of this displayed. We can see, yeah, a set of toy blocks, action figures, dolls. This looks more like Santa's bag of toys than coal and mold and worms and earwax. Am I right? Excellent. So we could go ahead and extract all these files. I'm going to create a new folder on my desktop before I do this so I can save all these as bag of toys. And now that that's been created, let's extract to that folder in our desktop. Click OK. And there we go. Now inside the bag of toys, it looks like it actually had the original file path kind of nested in here. So we have users and then specifically Santa for his account moving into his desktop and his bag of toys. We could eventually find all of the original contents of Santa's bag of toys. And we've successfully recovered all of these original files. So Santa will be so happy. We basically saved Christmas. Now on the bottom left, you might actually be able to notice there are, in fact, 228 original files in here. If you were to explore inside of the UHARC utility, you might have actually noticed that it displayed that for you right away. 228 original files of all of these toys that we might be able to give to children across the world for Christmas. And Santa has been saved. Let me submit the Grinchiest Christmas of all because I forgot that. But then as we download and save a copy of this bag of toys UHA archive, we have that. We were able to keep that and see it on our desktop. We wouldn't have been able to pull it into our analysis machine, but we could download it from the repository. The analysis machine just doesn't have internet, so we couldn't be able to easily pull that in. After we've uncovered this password, we have everything we need, right? We were able to extract the archive. When we double-clicked on it, we opened up the utility, and we were saving all of the original toys. With that, you've successfully recovered the original contents of Santa's bag of toys. You can view these in the Windows Explorer file browser to see how many were present. How many files were present? We took note that there were 228. And that's it. That's all that it was. That was our task. That was the Day 8 TryHackMe Advent of Cyber exercise that I had fun putting together for you. Now, hey, note, I really was trying to figure out what's the best way to do some of this and get the learning in place, because I like to have sort of an integrity check at the very end to make sure that you have legitimately done and successfully recovered something. So I thought, maybe I could have the users, or I could have the players actually create their own bagoftoys.zip, the same way that Santa had originally. But that way you'd fully recover, the threat actor's bagoftoys.uha and then your restored.zip, and maybe take the hash of that zip file to verify, hey, you had it all correct. You had all the files properly saved. But depending on the zip tool that you use to bundle that all up, the hash could be different and there wasn't a consistent answer, and it didn't really work all that well. Especially, some folks might want to be doing this in Linux or doing it on their own machine and not all in the Windows VM to begin with. And I thought, it's just not going to work out well. I considered maybe we want to really see the contents of each file to make sure it is in fact what it was. Maybe if we put all the contents of these toys and the files together, you could hash that and submit that for a flag. But then you don't have an easy, readily accessible way to do that in Windows, maybe as well as you do in Linux. So I cut that as well. And we just decided, and I opted, hey, let's use the total number of files present in the original bag of toys. So 228, cheesy number, kind of a silly thing to end off on. But I hope at the end of it all, you had fun and you learned something new. I don't know if you'd seen Shellbags before. Maybe some of you are already super familiar with Git, and that wasn't too big of a deal, but maybe some folks hadn't seen that weird, wacky UHA file or that UHARC archive and compression utility. So I hope there was some fun insight there, and I really hope you enjoyed this one. And I had a ton of fun putting this together. A special thank you to TryHackMe for letting me join them in creating and helping out with the advent of Cyber 3 here. It's been an honor, as always, and I really am excited to see everyone receiving and playing this. So please tag me in social media, take some cool screenshots, and maybe share it out in the world, Twitter, LinkedIn, Facebook. I don't know. You guys know I'm out there, and I'd love to see anything you're willing to share, and I appreciate all the success that might come from this room, this task, and you completing the day 8 activity. Thank you for playing and having some fun and enjoying the TryHackMe Advent of Cyber. Thanks so much, everybody. I love you. I'll see you in the next video. With